Alright everybody, in this video, let's discuss the third topic of chapter E, significant figures. Okay? Significant figure is very important in our college chemistry 1 and college chemistry 2 because we need to follow all of the rules regarding significant figures through all of our calculation and data collections. Okay? So it's very important for you to have a good understanding about it. And that means you need a lot of practice. Okay, all right. Let's take a look at the rules of significant figures. Okay, the rule number 1: all non-zero digits are significant. Okay, so well, this is very obvious. Okay, for instance, if you have 123.2, all 4 digits are non-zero. So for this number, it has 4 significant figures. Okay. The rule number 2: interior zeros are significant. Okay. For instance, if you have 3004.6, well, what is the interior zero? Okay. If you have zeros between 2 non-zero digits, they are interior zeros. For instance, you have 2 zeros between 3 and 4. So these 2 zeros are interior zeros. And according to rule number 2, they are significant. Okay, so for this number, it has 5 significant figures. Rule number 3: leading zeros are not significant. Let's use examples to demonstrate. Okay, 0.0006. As you notice that you have 4 zeros on the left side of the first non-zero digit, which is 6 in this case. Okay, so they are defined as leading zeros. They are not significant. Okay, so in this case, it has only one significant figure. One more example. 0.0378. Well, in this case, you have 2 leading zeros. The zeros on the left side of the first non-zero digit, which is 3 in this case. Okay, so these 2 zeros are not significant. And if you count all the other non-zero digits, 378, so they are significant. So you have 3 significant figures in this case. This is the rule number 3. The rule number 4, trailing zeros. Well, in this case, you have to be specific. You have to deal with 3 possibilities. Okay, the first one is the zeros, trailing zeros after a decimal point are always significant. Okay, what does that mean? Let's take a look at this example. 45.000. Okay, you say these 3 zeros are after this decimal point. Okay, so according to rule number 4a, these 3 zeros are significant. So for this number, you have 5 significant figures. Okay, let's take a look at rule number 4b. If you have trailing zeros before a decimal point, then they are also significant. Okay, one example here, 140.00. Okay, as you notice here in this example, you have 2 zeros after this decimal point, and you have 1 zero before decimal point. So according to rule number 4a and 4b, all 3 zeros are significant. Okay, so this number has 5 significant figures. Okay, this is the rule number 4b. The rule number 4c. Okay, if you have zeros before implied decimal point, okay, they are gonna be ambiguous, and we should avoid this kind of situation. What do I mean by that? Okay, for instance, if you have 11,000. You don't see where the decimal point is, okay? And in theory, we can always assume that the decimal point is right here, but you won't see it, okay? You won't be able to see it. So in this case, what should we do, okay? In this case, if you have this kind of implied decimal point, then you can always treat these 3 zeros as the trillion zeros, okay? So you are going to count them as significant, okay? So in this case, you can always say that this number has 5 significant figures. But as I mentioned, we should avoid this kind of situation. How do you avoid this kind of ambiguous situation? Then the answer is you use significant figures, okay? For instance, for this number, okay, let me erase this implied decimal point. For this number, okay, you don't see the decimal point. By using scientific notation, you will see it, okay? The implied decimal point, you move it to your left, okay? 4 times, okay? So that means that you have 1.1000 times 10 to the 4, okay? When you write the decimal parts of the scientific notation, you don't drop zeros. You keep all of the zeros, okay? Now it's easier for us because when you look at this part, okay, you have 3 trillion zeros and 2 non-zero digits. So the significant figures for this number is going to be 5. Okay, and please remember when you count the significant figures for scientific notation, you ignore the exponent part. Okay. All right. So this is the rules. Now let's do some practice. Okay. Take a look at this A. Well, you have 2 types of zeros. Leading zeros, of course, they are not significant. Trillion zeros, they are significant. Okay, so for this number, it has 4 significant figures. Example B, you have 5 leading zeros here. They are not significant, and 1 non-zero digit. So significant figures would be 1. Example C, 3 zeros between 2 non-zero digits, they are significant. Okay, so significant figures would be 5. Okay, now D. Well, as we mentioned a moment ago when we discussed 4C, the rule number 4C, okay, we said that for scientific notation, you ignore the exponent part when you count significant figures. So you are going to focus on the decimal part. 1.000, you have 3 trillion zeros. They are significant. Okay, so for this case, it has 4 significant figures. For example E, you have 4 trillion zeros, 1 non-zero digit. Again, significant figures would be 5. Okay, so these are the rules that we need to follow when we figure out the significant figures. Now, the next thing that we are going to discuss is how we follow significant figure rules when we do calculation. Okay, so we're going to bring our discussion to the next level. Because when we do calculations, we need to follow different rules based on what types of calculation you are doing. Okay, here, some basic rules. If you are doing multiplication or division, then the significant figures of the results should be the same as the factor or the number with the fewest significant figures. Okay. let's go through all of the rules before we talk about examples. The rule number 2, if you are doing addition or subtraction, then we should follow the decimal places in this case. The decimal places of the result should be the same as the factor with the fewest decimal places. Okay, can you see the difference between the rule number 1 and rule number 2? Rule number 1, fewest, let me use the red color to highlight. Okay, you need to use the number with the fewest significant figures. But the rule number 2, you need to check which number has the fewest decimal places. Okay, so that's the difference. All right, now the rule number 3, rounding. Okay, because we need to round the number sometimes to get the right significant figures of the final answer. Well, you need to round down if the last digit dropped is 4 or less, and you need to round it up if the last digit dropped is 5 or more. Okay, again, we will use the examples to demonstrate. The rule number 4, if you are doing multiple step calculation, then you only round the number for the final answer. You do not round the numbers for the intermediate answers. Okay, all right. These are the rules that we need to follow when we do calculations. Let's take a look at those 4 examples. Okay. Example A. It is a combination of subtraction and division. Okay. Apparently, we need to do subtraction first because it's inside this parenthesis. Okay. So we need to consider this part first. Okay. Remember, when you do subtraction, you need to follow the number with the fewest decimal places. Well, if you take a look at these two numbers, okay, this number has 2 decimal places. This number has only 1 decimal place. Okay, so for the intermediate answer of this subtraction, you need to have 1 decimal place. Okay. If you do the calculation, it will give you 336.99 and then divide by 5.3. Okay. Well, as I mentioned a moment ago, this number should have only 1 decimal place because this number has a fewer decimal place. Okay, so we are supposed to have only 1 decimal place of this intermediate answer. However, according to rule number 4, if you are doing multiple step calculation, you do not round the intermediate answers. Okay, you keep those digits as many as you want. Okay, to be accurate at the end for the final answer. Okay, so here for this intermediate answers, I would like to keep 2 decimal places. But what I would like to do is I would highlight the decimal place that I am supposed to have. I highlight this 9 to tell myself that we are supposed to have just 1 decimal place. All right. If you have only 1 decimal place, that means this intermediate answer should have only 4 significant figures. That is important for our next step. Okay, let's continue. All right, this intermediate answer divided by 5.3, okay, that will give me 63.58301. Okay, we are not reached the final answer yet because we need to consider the significant figures of this number. Now let's consider significant figures. This is a division. Okay, according to rule number 1, if you are doing division, you need to follow the number with the fewest significant figures. This one, as we mentioned a moment ago, it is supposed to have 1 decimal place. That means it is supposed to have 4 significant figures. For this number, it has 2 significant figures. Therefore, the final answer should follow the number with the fewest or fewer decimal significant figures. That means that this final answer is supposed to have 2 significant figures. All right, so that means that should be 64. Okay, why do I come up with the 4 right here? Because according to rule number 3, when you run the data, you drop the tail here, but since this number is 5, so you need to run it up to get 64. And according to the significant figure rules, this kind of situation is ambiguous because you don't see decimal points. Therefore, we need to use the significant figure, the scientific notation, to write this number. Okay, you move this implied decimal point to your left once, so that gives you 6.4 times 10 to the 1. It looks weird, but this is how we deal with this type of situation. Okay, now example B here. Okay, you have multiplication and addition. In this case, we need to do multiplication first. Okay, well, let's do them one by one. Well, if you multiply these two together, you need to, because it's multiplication, you need to follow the number with the fewer significant figures. This one has 6, this one has 3. So the intermediate answer from this multiplication should have only 3 significant figures. Okay, so for B here, the multiplication gives you 58.710078. As I mentioned, for intermediate answer, you can keep digits as many as possible. Okay, and of course, then plus 332.58. Okay, well, as I mentioned, that this intermediate answer from this multiplication is supposed to have only 3 significant figures. So I highlight the 7 to tell me that I am supposed to have 3 significant figures for this intermediate answer. All right, now let's continue. Those two numbers, you add them together. Remember, when you do addition, you need to follow the number with the fewer decimal places. Well, if this number is supposed to have only 3 significant figures, that means it is supposed to have only 1 decimal place. This number has 2 decimal places. Okay, so the final answer of this calculation should have only 1 decimal place. If you add them together, that will give you, 391.2900078, and it is supposed to have 1 decimal place because this one has only 1 decimal place. Okay, now you run the number. Since this is 9 here, you need to run it up. Now it gives us the final answer as 391.3. Let's do more practice problems. Okay, well, let's take a look at the practice A first. Well, you have addition and multiplication. This whole thing here is a scientific notation. All right, now let's start. Well, we do addition first because the 2 numbers are inside the parentheses. Okay, all right. For this addition, as I mentioned, well, you have 2 decimal places here and you have only 1 decimal place. According to the rule number 2, when you do addition, you need to follow the number with the fewer decimal place. Okay, so the answer from this addition is supposed to have only 1 decimal place. Okay, all right, let's write the answer for Practice A, the intermediate answer from this step, okay? That is 990.11, okay? Times 8.1 times 10 to the 6. Well, as I mentioned a moment ago, this intermediate answer is supposed to have only one decimal place. So let me highlight the one decimal place that I am supposed to have. If this number is supposed to have one decimal place, then that means this number will have 4 significant figures. Okay, that will help us for the next step, which is multiplication. Now, for multiplication, this number has 2 significant figures. This number is supposed to have 4 significant figures. So for multiplication, we should follow the number with the fewer significant figures. Okay, so let me do the calculation first. That is 8019.891 times 10 to the 6. Okay, well, as I mentioned, that this number is supposed to have 2 significant figures because this one has fewer significant figures. But as you notice, that the problem is if you are supposed to have 2 significant figures, it's not that very obvious about how you want to drop the tail, right? So what I would suggest you do is you write the significant figures of this number first. That means you move this decimal place point to your left 3 times. Okay, that will give you 8.019. Oh, sorry, 891 times 10 to the 3rd, and you still have 10 to the 6th behind. Okay, now let's combine these two because we want to make it simpler. So that will give us 8.019 891 times 10 to the 3 plus 6, that's going to be 9. Okay, now remember, we are supposed to have 2 significant figures. We are supposed to have 2 significant figures. Now it's obvious about how you want to drop the tail, how you want to drop this 5 digits. Okay, because this digit here is 1. It's less than 5. Okay, so after you drop the tail, it will give you 8.0 times 10 to the 9. That's the final answer. Okay. Now practice B. Okay, you have division and you have subtraction. We need to do division first. Okay, again, for division, you need to follow the number with the fewer significant figures. This one has 3 significant figures, 4 significant figures. So for the intermediate answer of this step, it is supposed to have 3 significant figures. Okay, so for practice B, this step will give me 0.3243, and you have 5.01 behind. Okay, as I mentioned, that this number is supposed to have 3 significant figures. Okay, because of this. Okay, and I will highlight 4 to tell me that I am supposed to keep 3 significant figures. Okay, all right. Now the next step is subtraction. We need to follow the number with the fewer decimal places. Okay, this one is supposed to have 3 significant figures. That means it is supposed to have 3 decimal places. Okay, this one has 2 decimal places, so the final answer is supposed to have 2 decimal places. Okay, so if you do the subtraction, it will give you negative 4.6857. We are supposed to have 2 decimal places of this number, so it's supposed to drop the 57 and keep the rest. And because this is 5, So we are supposed to round it up. So that will give us negative 4.69 as the final answer. All right, so these are, I hope this practice can help you understand how we deal with significant figures in calculation. Let me know if you have any questions.